The evolution of digital 3D printing allowed us to develop a new saddle without the constraints or limitations imposed by traditional production methods and materials. We challenged ourselves with one goal: innovate faster to make the cyclist's life better. Thanks to this one-of-its-kind combination of process and material, we've been given the chance to develop a product 5 times faster, creating and field testing hundreds of iterations. Being applicable to mass production, this technology completely remaps the traditional manufacturing process, accelerating and leaping over all intermediate phases, from an idea directly to scalable production. The adaptive saddle padding is crafted by Carbon using its revolutionary digital light synthesis technology. DLS is an additive manufacturing process which uses digital ultraviolet light projection, oxygen permeable optics, and programmable liquid resins to produce parts with excellent mechanical properties, resolution, and surface finish.
Our goal was to create a bike saddle that would adapt to rider's body. We wanted to provide performance by simultaneously improving comfort and stability. However, the major component that was missing was a new material that would allow to develop specific seamless zonal cushioning.
Elastomeric lattices featuring carbon resin are well suited for this application, as they allow for an infinite variability of saddle densities, making them perfect for cushioning, impact absorption, and vibration dampening. Using carbon technology, biomechanists and engineers have unprecedented possibility to design and manufacture multiple functional zones within the saddle, tuning each of them separately for specific mechanical properties. Carbon DLS technology allows our designers, engineers, and sports scientists to precisely address cyclists' needs. To produce the new adaptive saddle, we used pressure mapping data collected from both the world's best professional cyclists as well as amateur riders.
The demands and needs of a pro rider are really different to a recreational rider. A pro rider needs a lot of support, needs to feel the saddle. He wants that feedback from the saddle. With adaptive technology, with this 3D printing, you can get that in the place where the pro rider needs it. But at the same time, you can provide amazing cushioning support for a recreational rider doing a really long ride when they just need to feel comfortable.
We analyzed the data collected from our pressure mapping system. Then we researched which saddle would produce a better, smoother and performant ride.
The result is a saddle divided into 4 key functional zones, each of which has been engineered for a distinctive cushioning and mechanical response, progressively and seamlessly joined.
So with this new technology, you can increase the support in some areas and decrease it in other areas. You want a soft nose on the saddle to rotate onto when you're on the hoods, you can have it. If you want more support on the sit bones when you're climbing, you can have that in the same saddle. So with the advent of this new 3D printing technology, what does it mean to the saddle world? Well, in the past, it was pick your foam density, that's it, from front to back. Now, we know from all of our pressure mapping studies that riders ride in different styles, different people ride in different positions. If you could choose how much support you wanted where we're in your saddle, that would be great, wouldn't it? And that's what this technology gives us the opportunity to do.
Comparing adaptive with a traditional saddle, we can see how we were able to reduce pressure of about 60%, improving stability and weight distribution.
Professional cyclists and amateur riders were tested in both the Fizik labs and on the road. During each development phase, every iteration was carefully tested. A great focus has been put on understanding how the pressure patterns change according to different bike geometries, riding positions, and riding styles.
Body zones have different characteristics. Ischial bones, soft tissues, nerves, blood flow are involved differently in each riding position. This saddle adapts to them.
The first adaptive saddles are based on our Antares shape. Antares is Fizik's most popular saddle shape, improved by years of continuous refinements. For Antares, we chose a full carbon platform with an extremely lightweight and stiff interface, ideal for more direct power transfer.
We were able to combine years of experience in biomechanical research with a new material that allows us to provide a new generation of paddings with specific zonal cushioning and progressive support.
When we pedal, we move a lot, and most parts of our body are involved. Each movement has a direct impact on a specific part of the saddle, and that's why we divided adaptive in 4 different zones.
Each of these key functional zones is engineered with a distinctive cushioning and mechanical response, joined together progressively and seamlessly in the same padding. The zone at the nose supports the rider while pedaling in the most aero position. The zone in the middle supports the rider while pedaling in the hoods, providing the right amount of stability and support while maintaining healthy blood flow. In the ischiatic zone, the saddle supports the sit bones with a compression gradient that provides comfort and balance. At the back, a more open pattern provides rear stabilization while also reducing weight. Antares versus Evo Adaptive is available in 2 sizes. A 139mm wide option, weighing 147 grams, and a 146mm one, weighing 154 grams. They both have an overall length of 274mm, a nose length of 151mm, and a stack height of 54mm. Here, Fizik provides instruction for the installation and the adjustment of the adaptive saddle.
On top of the saddle, there's a green line. It indicates where the saddle is 75mm wide. That's what we consider the center of our anatomical body.
This line is to be considered the starting point where to adjust saddle height and the setback. The 75mm line is also helpful in leveling the saddle. The saddle is very easy to clean. Even with the filthiest road muck, all you need to do is simply hose it off with water. Whatever gets in, gets out. We've put it through the most severe tests, simulating accelerated weathering of the material, exposing the saddle to temperatures ranging from -20 to +70 degrees for 12 days at different rates of humidity. The saddle can withstand the harshest of the conditions over time and does not deteriorate, thus preserving its mechanical properties. Adaptive also meets the ultraviolet resistance requirements for sunlight exposure, showing no signs of discoloration after up to 300 hours of accelerated UV aging. To ensure Adaptive will endure and perform throughout its life, we tested and proved its wear resistance by following strict protocols, such as abrasion and fatigue tests simulating thousands of trips cycling.